And good morning, everyone, and welcome to the fourth in our Learning Engineering Speaker Series. I'm Stephen Spencer of C-ADL Multimedia, and C-ADL's Major Stevens is monitoring chat. And it is my pleasure to introduce today's speaker, Andy Johnson, an expert with over 2 decades of experience in shaping the landscape of technology standards across the U.S. Departments of Defense, government, industry, and academia. Andy currently serves as the Specifications and Standards Manager for the Advanced Digital Learning Initiative, where he plays a pivotal role as a DoD contractor. And throughout his career, Andy's been instrumental in the development and promotion of foundational learning technology standards, including SCORM and XAPI. His work has helped create the frameworks that underpin modern digital learning ecosystems. While Andy's contributions to standards are widely recognized, his true passion lies in designing and enabling learning experiences that are not only effective, but also engaging and entertaining. And today, he brings that passion to a critical and timely topic, the role of subject metadata in empowering artificial intelligence within the field of learning engineering. So please join me in welcoming Andy Johnson. Andy, thank you so much for joining us today.
You bet. Thanks for the intro, Stephen. Let me share my screen and we can talk about learning metadata and its role in learning engineering, but also how it can impact artificial intelligence, how the landscape has really changed and is now, I would say, prime for that interaction with artificial intelligence with the advent of this new process called learning engineering. So Stephen gave me a great intro. The one thing I'll just say, I'm a government contractor. We're called CETA contractors. We're kind of made to outlast the government billet system. So in the U.S. Department of Defense, we see a lot of people get promoted, move on. The contractors are kind of there to make sure that efforts continue, even though they can be moving throughout their careers. So while I don't have the power a government person might, and anything I say doesn't necessarily carry the weight of the government. I've worked with them for long enough that I feel that my weight, what I can say, does matter. So I want to talk first about the old AI. So this old AI is adaptive instruction, and this is kind of hype. The hype of this was always just in time and tailored learning. That was always the kind of the moniker we had for it in training transformation back in the U.S. Department of Defense in the early 2000s. Just-in-time training. And then the idea is that by collecting vast amounts of data about the learner's history and preferences, we can then influence what activities they're going to get, when they're going to get them, really having this idea of, we even call it a personal assistant for learning at one point, the PAL, a little too close to HAL, for those who are science fiction fans. But the idea that it would know enough about you to be able to make recommendations just through linking the data about their learning activities with their personal activities, and that somehow all these would link together perfectly, and we could then deliver these experiences just how you need them. And really what this amounted to was the ability to test out of content using a pretest. Once in a while, we'd see this within individual courses. You take a pretest, and then you're able to adaptively get out of certain portions of it. If you were really lucky, you would have sometimes where if you took the same course consecutive years, it would remember what you knew, or it might just give you a really brief pretest to make sure you refreshed correctly. And the unicorn, which we would really rarely see, would be if something I had from one course translated into another course, testing out of those things. Very rare for that to happen. Now, this way of thinking is not dead, but it's more of an integrated path. So we're going to have handoffs with this and our new AI. And the new AI, and the hype was/is, it's an intelligent agent that will detect your every activity. So not so much that I need to actively engage with data, but that the artificial agent is aware of these types of things. And AI has been hyped for a long time, and it's in a lot of ways, it's functioned very similarly to adaptive instruction for a number of years, where you would have this brain type of system that would understand what you were doing. You wouldn't have to feed it data specifically, it would just know. But it was always really limited, and it's still to some point is lipstick on a pig, where it's still at its core just making algorithmic decisions. We're not really seeing anything yet that indicates that a machine is learning from your habits. It's more still less just pulling in data, pulling in calendars for scheduling type of things. And from an individual perspective, we have not seen this transformation yet, but there are exciting things in AI that are coming. Generative AI and large language models, those specifically start to open some doors for how we can think about how AI can work with individuals. Learners aren't yet seeing that benefit, but I'd say very much of achieving what new AI can do is getting to what the old AI's first promise was, which is figuring out how can we collect valuable data so that we can do adaptive instruction, and then ultimately we can enable some of these advanced things we'll see with new AI. So I wanted to talk about some of the problems that we've solved now that really do change the landscape for what AI can do. So one thing we achieved in the early 2000s, which was SCORM, the Shareable Content Object Reference Model, was content and system interoperability. The idea that I could take content and apply some standards to it, take a course package in this case, and I could make it so it was a standardized import and runtime. If that LMS would do that, I could track and store data into a database, and these things would function. Didn't matter which LMS I had, didn't matter which course I had, as long as they fit standards. We had content and system interoperability. And from a software perspective, this is great. It really did make things congruent. However, the thing we were missing when we developed SCORM, and which we went after in developing Experience API, or XAPI, was data interoperability. So yes, we managed to get that import runtime. All those green checks you see, still valid. However, once we got into these databases, we couldn't really go across them without realizing, oh, wow, I might not have stored that data in the exact same way. If I were to try to integrate two SCORM databases, there was zero guarantee it would work, and I'd say the odds that somebody designed those database systems the same, very, very little. So the idea of gathering a bunch of databases and putting them into an external database instantly is not a thing. Reports and analytics coming out of that external database, or even coming out of each of these databases in the same way, not the same. This is a large complaint I fielded many, many times from SCORM users that would say, I want to change LMSs, but I have so many custom reports that come out of my system that I can't, because they're tied to the database. So what we want to do with XAPI is we have data interoperability achieved. And it's not even just with LMS systems, it's with any type of system. So training simulations, human resource systems, augmented reality, virtual LVC exercises, live virtual constructive, all those types of things can report to databases. It's an Experience API format. We can grab all those databases, share them all in one large external database or series of databases, and we can get reports and analytics that can connect to any of these. And because the data interoperability has been achieved, now we can do those types of things. That's going to be really important, because that external database could be what AI is using, or that collection of databases. If it was trying to use these types, it's not going to get a common baseline for what's going on. So with that part of the problem really solved, I went to ask AI, let's talk about learning engineering. So what's in a learning engineer's toolbox? Actually, I did want to take I didn't put these slides in, but I did want to just talk to the two diagrams we often see with learning engineering, because I'm going to reference through AI, kind of reference some of these things. So the idea that there is this this creation wheel or implementation wheel for how learning engineering works, goes creation, user testing, investigation, really engineering a process that is a spiral development type or waterfall model, however you want to look at it. They've had many names over the years, but the idea that there's some sort of cyclical model that allows the processes to repeat on themselves and be organized. And then the idea that there are learners, but then there are also a number of roles that we're going to see, roles/disciplines in the learning engineering field that ultimately contribute to a shared understanding that help learners and other stakeholders. So I just wanted to share those two diagrams. These are key to learning engineering, but if we think about how these next slides are going to think about how we're applying these. So what's in the learning engineer's toolbox is what I asked AI. And it's in learning sciences, which is great. We do see that, and a lot of the the contributions have been through the sciences. Data instrumentation and analysis get critical. If we think about those reports, we need to know not only what's the learner doing, what could they do, and we need to have accurate data instrumentation to do that. Human-centered design, so going back to how can we help the learner? How can we design things so it's easiest for the learner? A lot of what we saw previously was developing our kind of archaic or non-user friendly interfaces that were focused on getting data. Didn't work out necessarily that well. I'll show an example of that later. Lean/agile development, so that's what you saw with the model, the processes, data design and engineering methods, so methods to those processes that go together, and then ethics and standards. And I would just say most of the rest really rely on these. If we don't have standards and they haven't been developed ethically, we're not going to be able to do anything that's repeatable and that's transferable. And especially from our perspective, and anybody who's working in a government or Department of Defense, we need to have system congruent, because a lot of what happens is we don't make unilateral purchasing decisions as a department that affect everybody. Departments are allowed to operate independently, can buy their own things, own systems. So we cannot necessarily just rely on those to magically integrate. And we don't want to get together tiger teams every time we want to do that and have those long, expensive processes. Standards can save us a ton of time. So then I asked AI as well, so we have that kind of standards in our back pocket. What are the phases of learning engineering? And you can see here, define the problem, research, brainstorm, imagine, plan and select, create/build, test and evaluate. AI apparently loves to use exactly two verbs to describe things. Improve, redesign, and then finally share the solution, which I was happy to see that AI picked up, that we are ultimately trying to share what we have produced. That is part of learning engineering, is to make something that is designed in a way that somebody can take it and use it and share it with other people. That's ultimately something we want, and that's when we talk about designing standards, that is something we're doing. So I was really happy to see that. I also couldn't help but put kind of this old stamp, this ISD stamp, instructional design, the ADDIE model, if you will, that okay, really defining the problem, that's analysis, researching, brainstorming, and planning, that's the design phase, and then we actually create it, development, and then test, evaluate, and improve and redesign. That's kind of that. It's the idea of the cycle back, but the implementation, evaluation, and then running that cycle again. So if we kind of think about that design phase, all these different phases for learning engineering, it does really look like the old instructional design model. But we can apply this to any type of activity. It doesn't just have to be learning. It can be for training as well. It can be for it doesn't have to be just for courses. It can be for simulations, live exercises, etc. So why bring all of this up? I want to talk now back to the metadata portion of this, which is looking at the previous ways that we have done metadata in the past. And both of these were colossal failures. So on your left, you will see a user interface that is designed to allow somebody to create metadata about a thing, and it goes through all of the different nested properties of learning object metadata, one of the first metadata standards. And if we're actually able to populate this, you deserve a gold star, because it means you knew 100 different specific properties of metadata, what they meant, what data format was supposed to go there, and you were able to do that. And if you created that metadata record, that was amazing. And ultimately, it wasn't really used, because in order to search, for somebody to search on that metadata, they would have to have an equivalent level of understanding, know where to look in this complex model, and find the specific field, and then run their own search on that and hope that they got a match. So that, matches there were extremely hard to come by. And asking somebody to build a record like that was very difficult, and they didn't do it. So the other approach was on the right, where essentially here's your LOM, your learning object metadata again. and somebody goes through the trouble of building this thing. Maybe they put everything in its proper location, build it out, just to have somebody take that whole structured XML file and essentially break it down into a series of words or taxons and run it through a Google type search. To say, I don't care where you put it. If the text is in there, I'll let somebody just do an elastic type of, well, not even necessarily elastic back then, just a search on it. And if a word matched, then I'll return the object. So basically, all the work you put in didn't matter. All the contextualization of those properties didn't matter. Those were the two popular models, and neither worked, which is why metadata did not work really unless it was a homegrown system. But the idea of interoperable metadata did not work. So that's why it didn't work. So I guess let's talk about, well, what is metadata? So I described why the solution didn't work. You can imagine, regardless of the type of data, the idea of somebody putting in a lot of time and then having it undone, or putting a lot of time and relying on expertise doesn't work. So we used to say metadata is data about data. That doesn't really make a lot of sense. But really what we're getting at is, let's talk about from a user perspective, end user design. Metadata is structured information that describes, explains, locates, or otherwise makes it easier to retrieve, use, or manage an information resource. That's what we're trying to do with it. So let's make sure we're describing it in a way that talks about what we actually intend to do with it. Now, if we think about, there's a lot of different roles when we think about metadata. If I want to design adequate data that is then searchable to perform these different high-level functions that we expect, that we want our end users to benefit from, there's a lot of different roles. And these are similar to the learning engineering tree. I broke them out a little bit differently, just in terms of how I think most content acquisition and development processes work. So I broke them out as there's an instructional designer. That's the role that really makes the learning happen. They take a little bit from what the contract or the program manager says, and they work with all the subject matter experts and technical people to create the product. They're also the strategist in delivery. So this is kind of the person that really holds the team together and holds the team accountable. And a lot of times you'll see instructional designers have many hats and play multiple roles in this, and that their expertise is often goes across a lot of these roles, even if they themselves don't end up doing all that work. That's why I've listed them first. A lot of one-man shops back in the early 2000s for doing this. So the instructional designer did a lot more than just the instructional designing role. The program manager / customer, and I put that here because I do think that sometimes the customer does know exactly what they want, to the point where the program manager is really just directing traffic, but a lot of times they don't. So I find this role as the one that knows or has relayed the information of what the content is supposed to be and do. When these requirements are created, there had to be enough information at some point to create a contract that had very rigid expectations. In fact, there should have been, that we know what we're building, and we know why we're building it, what we're building it to, which types of learning outcomes we're expecting. So that there should be that pie in the sky person / contract that's available that we're looking at. The technical developer. So this is the role that actually hooks up all the technology and potentially executes authoring, webhooks, and even technical data configuration. When I say webhooks, I'm talking about most of the content we're talking about is HTML based. So building in ways that the content, that HTML content can either grab data or send data out based on what the learner is doing in HTML in that content. And this person has the technical skills the ISD might not have, but will still require strong direction from the instructional designer. Their technical prowess is only going to take them so far. They can code, and they might have limited knowledge of how to technically implement a standard, but they won't have the design knowledge likely to translate that. Subject matter expert, the SME. So this is the role that actually knows the subject matter of the material used to create the content. The ISD has the knowledge to how to help the learner learn, but they're often going to be not necessarily experts in a specific domain, and they might not care about a specific domain. So the role of being that domain expert is that subject matter expert, and they will know the appropriate expectations of learners in that domain. And then the final role we'll talk about here is learning management system administrator. It doesn't have to be a learning management system per se, but really it's the person that is going to deal with deploying that content in a specific system. And even in some cases, we'll talk about when we talk about metadata, it doesn't have to be an actual it doesn't have to be a virtual object. We can describe real world physical locations as well. So in this case, this might be somebody who's responsible just more for the environment, not necessarily has to be virtual, but typically it's going to be a virtual environment. The system might be a content repository as well. So I want to make sure that a lot of the properties that there's a lot of the use cases that are met do have to do with deployment on systems, and the idea that there are versions of different courses or content. And so the lifecycle management of that is really going to be important. So there are learning opportunities that are enabled by this the specific metadata standard I'm going to talk about today is called Learning Metadata Terms. It's the IEEE 2881 standard. It's been in development for a while. It was published October 3rd, so it is now a full XAPI standard. And there are a lot of things this does. It does do the traditional ways to describe a course. So it has your title, description, keywords, but it also ties it to specific audiences. One thing we're realizing that is in this age where one of the big paradigm shifts we saw with implementing Experience API and getting that data interoperability is that we want data to be referenceable through identifiers. So if I am describing a specific learning activity, I want that to have its own unique identifier so I can find that activity no matter where I am. If I want to describe a specific learner, specific person in a space, I want that person to have an identifier that I can grab across space. If there is a learning outcome, I would like that to be described or referenceable in a way that is that I could grab across space. So you need a lot of what we call unique resource identifiers or URIs. It's similar to URLs. URLs usually have to do with finding something on the web. It doesn't have to be on the web, but the idea that there's a universal locator or identifier for this thing, and ideally that identifier is also a locator that you were to resolve it would get there. So the reason I bring this up in the context of audiences is that what we want to do is start to describe audiences in a way that are uniquely referable to. So if I have an audience that is specific to, let's say, United States Department of Army, I want that to be a specific audience, and I want that audience to be unique so that if anybody else were designing for that specific audience, that is brought up. So I don't have to necessarily disambiguate the words U.S. Army if I actually mean United States Department of Army. If I mean the specific thing, I want to be able to refer to that. It has both learning resources and learning events. Now, learning resources I put shelved there because the idea of a learning resource goes back to that typical learning engineering process and the idea of shareability. A learning resource is defined in a standard that's called the Learning Resource Metadata Initiative. They do a really good job of describing learning resources, and this LMT standard grabbed from that. So the credit is given to the LRMI group for these learning resource definitions. And learning resources, there are two key aspects to it. One, that it's something that can be copied and shared. So there's not just one copy of the thing. There can be many. So I can use it, you can use it, and that it can be moved around. So the idea that it's locatable and it's able to be moved around in that multiple environments can use it. It's set up for that use. Now, we recognize then that there's also the deployment of not necessarily always learning resources, but there are deployments of things, and there are things that aren't necessarily shareable across that we want to track. And we call those learning events. The way we kind of disambiguate that is if you could oversleep or if you're in the wrong spot, you will miss that learning event. The idea is it is contextualized to time and space and resources. So if we were to think about a course that sits as a zip file in a learning repository, that's a learning resource. Whereas if that course was active on a learning management system for a period of 1 month, that's a learning event because it's only active for a certain period of time. And that learning event might have an instructor associated with it. It will have classmates associated with it. All these things that contextualize different events. And the value of that lies not so much in the metadata definition, which there is value there, but when we link back to learners, the idea of contextualizing around, well, where was that training done? What were the weather conditions that day, if we're thinking about a physical exercise or even simulation environment? Who was in the group with them? Who is the instructor? All these things matter, and not in the same way that a learning resource that I would search for with metadata is, but more related to how am I contextualizing the learner's proficiency or success in that activity relative to a learning. The other things we describe, the ways to relate parts, deviations, or a session of the thing. So taking that thing, how can I relate that course on the shelf to the courses that are out there? How can I relate different people who have taken that course, maybe put a new skin on it, maybe changed a lesson or two, but it's still essentially we consider it mostly the same thing. How do I track derivations of that? And then how can I relate the different pieces of a learning course or learning resource to each other, parts of each other. Management of the life cycle of the thing. So the idea that this thing is going to have versions. There's going to be new versions and old versions, and I need to be able to know when something has been updated. So there's some specific use cases we'll meet with that. Intended instructional and functional use of the thing as related to competencies, roles, or jobs. So we define two specific properties called teaches and assesses that get to the reason I've developed this learning resource is most likely to teach something or to assess somebody's ability to do something or that they've learned something. And sometimes that same thing, learning resource, does both of those, but then we want to relate those to outside competencies, outside roles, outside jobs that affect not only have I met the terminal learning objectives within this content, but how do those relate to external competencies, roles, jobs, etc. And of course, we want to have ways to extend and always describe learning resources and events. So that the ability to reach out and describe anything in any way is always on the table, even if the one of the 30 properties that this standard has defined doesn't do it. And I should say the ability, when you say the ability to extend, to create profiles, application profiles that are specific to learning, types of learning resources. So if someone has a course or a video, those are going to have different metadata properties that make sense to describe them. This standard doesn't try to match all of those, rather it leaves it up to application profiles to do that. So how do we fit learning metadata into learning engineering process? There is guidance on this, so I can grab at the end of that if people have a hard time copying it. Otherwise, grab that. You can feel free to grab that publication. Worked on that with Defense Acquisition University, and in that report, there are a lot of ways that standards, such as the learning metadata standard, can be implemented. So we need to think of metadata three-dimensionally, which is who, what, and when. So rather than just this idea that there is a record that's XML based or something that needs to be populated, we need to start thinking of it in this who, what, who, and when model. So thinking of a data model in a standard and making sure that it meets my needs, extending it as necessary. And I should also say applying different profiles as necessary. So if I'm going to be working with courses, there is a course profile that Techniques report actually does have that course profile built in. You'll then choose an actor who best knows the data to populate that data. So thinking back to our 5 roles, everybody should have certain parts of that metadata they're populating because they're the expert. I don't want my LMS administrator to try to figure out what is the domain. If the domain is marksmanship training, I don't need that computer science person who might have never done any of this type of activity to be one guessing at metadata properties. And then when in the learning engineering process or ADDIE model, if you wanted to go back to old school, when is this time? When is it in this time period is the data known? So a lot of the properties, I would argue, before that contract is signed for its creation, a lot of that is known. I should know what my learning outcomes are. I know what my expectations are. They might get refined on the way, but the idea that I should know what the thing is before I'm building it. And then the idea of validation. Somebody should be validating the data, which has timing as well. So I might have the contracting people write up some of this originally, but then I'm going to validate it throughout the process. I might validate it during that development phase. And then help. It shouldn't be on these archaic tools to try to do things. There should be tools that allow easy collection. You don't necessarily have, the learner doesn't have to know they're collecting metadata. They could be answering questions. And that collection of data should be available, and it should be customized based on the role, and it should be available at the time that they need it. So what I can, so part of the document, I can bring it up. Let's see here. I actually won't bring up the document because I'd just be scrolling. But basically, there are tables in that document that look like this. And you'll see here, it's got the name of the property, the role of the creator of that property. So in this case, it's instructional designer, program manager. Sometimes I put it on different other groups that could exist, recognizing that not all 5 groups might not be sufficient. The timing of the application, instructions for actually implementing it, and then the validation process, recognizing there's multiple roles for validation, and then the timing of validation. Now, I didn't write this necessarily with a learning engineering aspect in mind, which is part of the reason I have that learning engineering to ADDIE adaptation, is so that this document becomes more usable. So if you think about the learning engineering phases, map that to ADDIE, you can essentially grab the timing of validation and the timing of application here. And there are about 70 properties defined, 30 that are specific to the LMT standard, and then about another 40 that serve to extend it to courses. There's other profiles that exist, video types of profiles. Really, any activity type you can think of should have its own profile to allow for specifics to be captured about that. So format, for example, or bit rate, those are important to video, not so much to courses, and not generally speaking to a lot of other types. So now we're going to talk about integration with other standards for metadata. And really, we think about this learning ecosystem. It's learner's activity, opportunities, learner profile, and then the idea that there's competencies that are going across these. And I'll talk to all these in a second. But opportunities is really what we're talking about with metadata. Which courses are available? What activities are out there? What types of experiences can I have? And all those types of opportunities are expressed through metadata. So if I can describe what the thing is, when it is, how it relates to me as an audience, and what I might learn from it, those are metadata expressions. Learning activity, there's already standard for this. This is the Experience API or XAPI, IEEE 9274.1. It's got a really long name there, but it's still basic. It's still XAPI. And this is what the learner's doing. So if I can express granular details of what the learner is doing, I can spit out different pieces of data that said, all right, the learner's registered. The learner has entered the training simulation. The learner has pressed button 3, which caused a shot to be fired. The learner has exited the training. The learner was successful in the operation. All those types of learning details can come out, and they're expressed through learning activities. The way we then connect those two are through another standard, shareable competency definitions, IEEE 1484.20.3. That's a full standard as well. And the idea is that we can connect to these different knowledge, skills, abilities, qualifications that say that, yes, this person did that, was able to do that, and I therefore feel that they're proficient at that specific skill. I feel that they specifically know the thing I just tested them on. And that can be expanded into things like jobs or tasks. I am confident this person would be qualified for this job based on these number of other things below that job that I expect them to do. The tasks, I know they can do the job because I've seen them proficient in every task that the job requires. So these competencies are intended to be things that can stack and roll up to connecting a learner to opportunities. A learner connects to opportunities that might interest them because they might know which competencies they might want. They might know what job they might want, and therefore want to be connected to opportunities. And the learner profile, this is something that kind of filters down into everything the learner's accomplished, what they know, what they want, their goals, their desires, the reasons they're trying to actually pursue a number of opportunities to gain competencies, and it's tracking all the learner activities, but at a more aggregated level. So this might have like all your course completions in it, all the competencies you've therefore achieved, certificates you have, goals you have, etc. So that's the learner profile. And the idea is, so kind of to talk more about how the activities connect through metadata. XAPI activities use metadata that's specifically part of those XAPI statements, and it feeds automatically into learning record stores. So that means that learning record stores have some sort of idea of every activity that expresses metadata. XAPI activities are intended to be unique and resolvable identifiers. When we talked about the URIs before, that's what we're talking about, that they are both unique and resolvable. Metadata is also intended to uniquely identify and locate activities. So there's a natural idea there that the metadata would then map directly to that activity, and the activity, if you resolved it, would return that metadata. So I can know specifically what that thing is and how it's described. And then anything XAPI can do can correlate a user's behavior to this, quote unquote, this type of activity or this specific activity. Both of them are applicable. So if I know that this person took content and they took it in an in a specific LMS or at a specific time of day, or an activity that had a specific style applied to it, and it was more successful for them, then I can correlate user behavior to that. And the learning events enable that as well. So all the different data I am tracking that have to do with learner success, I've contextualized within this activity having these properties. So then activity data, including instructional methods, audience, etc., all that can be correlated back to the learner and their success or lack of success. They also connect through competencies. So activities, they reference the competencies that teach and assess them. I spoke to that already. They can then allow searching through familiar repositories and find the right opportunities. So if competency repositories also exist, in addition to learning repositories, those two will cross-connect in this thing called a competency, which is knowledge, skill, ability, outcomes that are expected, so that as long as one person is defining it, those two opportunities can connect, and then you can actually work with the competency owner, because those are typically owned by credential providers. When I say that, so like if Harvard has their set of competencies, you might say generally, I might know calculus, but if I haven't mapped that specifically to Harvard's calculus, there might be some problems. So they ultimately control that, but my activity connecting through competencies can affirm the opportunity and the conditions for achieving that. So finding that learning opportunity, connecting it to the holder of that competency or credential, then can help guarantee my success by doing it. And then by searching it from a competency registry, which neither of these exist yet, ADL is working on these, you can provide a list. If you had just had competencies alone, you would have just a list of competencies, not necessarily this active connection. So by applying all these standards, what we're really trying to do is enable a learning marketplace. So if we think about like Amazon for learning, only rather than delivering it at your doorstep, want to deliver it to your brain, the correlations here work well. So that if you think about a product, products are described and are intended to have relationships to each other and to the interests of the buyer. They connect the buyer to these specific products and allows them to make decisions on logistics. When do I want that shipped? How do I want that shipped? You can discover complementary or necessary products. So maybe I didn't realize that didn't come with chain oil, for example, if you bought a chainsaw. And then physical dimensions, those types like height, weight, and length. The types of technical compatibility, those types of things. Those are all described in the product market. But the learning market is even more interesting because we can describe learning resources. We can describe how they relate to each other and to how the learner's abilities can be augmented, improved by connecting to that learning resource. It connects the learners to the specific entries to allow them to make decisions on their own logistics. So in the absence of AI, we can still empower the learner to say, well, did you know that this learning resource is connected to this competency? They can discover learning related to their opportunities or job, and discover tangents. So by thinking about by mapping it to, if larger collections of resources and competencies are mapped, I can have an idea of what the learning path is to get to what I want. So if I want a job, I can identify all the tasks I need to do with that job, all the competencies I might need to achieve, and I can know exactly then what my distance is. And all these things can, are right on the cusp of that AI, regardless if it's the adaptive side where I can empower the learner, or the AI side, which might then which takes it to the next level, which says, all right, I'm not going to necessarily just put a user interface in front of the learner. I can describe to them and recommend very specific things. And then mental resources. So my knowledge, skills, and abilities that I already have, my mental resource dimensions being known in the learning market can enable all this. So to think about then, what can metadata do for each type of AI? There's a lot that's going on here. So if we think about generative AI, by all the standards being established, we've provided the ability for the AI to learn these different data models, ontologies, taxonomies, et cetera, to then build things that can be consumed by other systems that understand those standards. You are now able to take and say, AI, take my existing learning content and apply the CMI5 standard to it. And it can do that. And then that output has a very good chance of being something that you could plug into a CMI5 system. Because these models are out there, because there are very specific technical standards that say that we can do that, we actually can have some confidence that generative AI can have a shot at creating a metadata instance. So you say metadata, or generative AI, build me a metadata graph about my learning resource that's conformant to the learning metadata term standard. And it can do that. Generative AI can also consume documents, such as contract proposals, and can populate them for human review. So it can read that in, give me a summary of that, or maybe even, hey, take this contract and write me some metadata for that. So we can take a lot of shortcuts that we couldn't before, or at least would have more confidence in those shortcuts because of the ability of generative AI to actually understand these models. Predictive AI. So this was our pie in the sky learning adaptation from before, but if we can connect learners to the rest of the ecosystem and adequately model their past, then predictions about their learning outcomes based on the paths they choose and interventions can be done. So thinking about if we can model all the past learners, we can predict future success. And if we think about that and we can model this successfully, we can actually start to use that for human capital management. So if you think about, all right, I know the ages of all the people that I have in this program, there are going to be people that are aging out. I can actually then look at the knowledge, skills, abilities of people who are in my organization, but not in those roles, and plot the distance and the time they would need to take that person's place. Or me as an individual, if I can predict if somebody's past performance, I can start to estimate. Well, typically people who have wanted to make this job jump have taken 6 months to do it. Here's how they've done it. But I found somebody who did it in 3 months, so maybe I can model that person. So by having all this data available, we can make those predictive analytics. And kind of in the same vein as assistive AI. So understanding that entirety of the ecosystem, the AI can break down the goals of a learner into that distance until their desired outcomes. So think about the distance to that job. Metadata is critical to understanding the connection of the learning opportunities to the prospective outcomes. So yes, I'm going to mostly use competencies to determine, all right, what are the tasks that I need to do for this job, break it down to the competencies I need, but that connection of those competencies to the specific learning resources that they're adequately described is important. Really, all the different parts of this ecosystem are important, so we can't really skimp on any of them. And then even conversational AI. So the idea of standards having refinement of terms, vocabularies, and being able to go across different domains means that model for the conversation is optimized. So if I know I am in the domain of biology, that's going to help creation of different types of data, but it's also going to understand the domain knowledge of that system. And by using large language models, we can recognize that we're working within specific standards and specific domains and marry those two together. And that's going to help the assistive AI doing any of these types of possibilities. So being able to ask AI with confining it to specific domains with these large language models, then it can really start to answer a lot of these adaptive questions that we've had in the past, but now are actually answerable through AI. But really, if we don't design data with that's principled, it's not going to work. So what can we do to help these learning engineering AIs to function? So there's 4 principles that I've listed here. And that's first, agree upon and document the properties per type of learning resources and events. So let's adequately say what these types are and then document the properties. So using learning metadata terms, what are the different types of learning resources and event? There are 30 properties defined that are applicable to all of them. Let's define specific types and agree on those. The names aren't important. It's just what we're tracking. Names are all ambiguous in this because it has to just do with what the data is. And AI can help us with graph technology really understand what we're trying to get at rather than what we're calling things. So syntactic or semantics are more important than syntax. We need to provide system access to edit and retrieve metadata. This is likely a new system, but the idea that we need to put this data out there and share it. If we're not sharing the data, the AIs can't consume it in mass. It can't learn from it. The AI is going to just go to the person who bid the highest and uses it the most, and it's not going to be applicable to everybody else. We want to assign metadata properties and workflows to specific roles in content acquisition. That report I showed you before is a good draft of that. You don't have to take it verbatim, but it's a good start. And then finally, create and register URIs for all learning resources and events with support from underlying processes and policies. So we want to define and make sure that they are unique. So have an identifier for every resource we're talking about and register it, make sure it's out there. If we can start to do these types of things, then AI systems that reach out, can pull data, can understand it. So at this time, thank you, everybody. I'm able to take about 15 minutes worth of questions. So I'll stop sharing, and so I can see hands and chat and all that type of stuff on Teams.
And you can ask questions either in the chat, or if you just want to raise your hand, you can ask them from there. And Major Stevens will be calling on any questions. So I had perhaps the largest idiot question that we're asking: how updatable is our system if we discover new types of data that we want to capture with this? How is it easier to update the metadata, or to go in with like a plan already when we start that defines exactly what data we'd be looking for?
I mean, having a plan up front is always good. What I just wouldn't waste time on is worrying about what to call things. Just worry about what you want to capture and have a description of what those are. And if you have just a series of descriptions or a series of questions you want to answer, that's more important. You don't have to do any of the figuring out of what it's called. That's the systems will eventually work all that out. So yeah, have an idea. It's a good thing to know what your expected outcomes are.
I'll turn this over to Major Stevenson. Thank you, Andy.
Commander Moget, go ahead.
Thank you, Chris. Andy, thank you for the presentation. Very insightful. I'm with the Royal Canadian Navy on the West Coast. 2 questions. One, all the conversations I've been involved in with regards to this standard and the idea of metadata has been in the context of defense. Can you tell me the extent to which academia, high schools, post-secondary institutions are also starting to have those conversations? Are they way ahead or same level?
I think they're behind. I think they're slightly behind. I mean, there's probably different pockets of excellence. I've seen those in a lot of the virtual universities where they're really starting to implement more learning engineering processes. But mostly it's because the shops are smaller. But I think the same principles apply where we just need to make things simple. And that's what the whole point of the standard is, not to inundate people with large questions, but rather just to say, you need just do the basics, but just keep track of everything in a way that that you're identifying what specifically you have, because ultimately every single institution is going to be a caretaker of the content that they have and access. So if you're deploying learning, if you don't do these, if you can't do these basic things, it points to a fundamental problem that's underneath, which is you're not thinking about life cycle management of resources and of materials. So I think it's applicable to all. DoD is just a really easy and interesting use case because we have command over everything. We have huge populations, and the populations have to listen to us. We don't have that problem where we have to worry about we do have to worry about motivation, but not as much that we have to attract specific people. Once they're in, they're in.
Thank you for that.
Yeah. You had a second question?
Yeah, the kind of a segue to what you were just describing, really. Over the next few years, the Navy is going to be buying an incredible amount of training material, some analysis work, some design work, some actual courseware from industry. And unfortunately, our requirements for industry to create content that adheres to the standards kind of, I think, was omitted over the years. I would like to reintroduce it. What I don't fully appreciate is from a statement of work perspective, how specific, how laborious would it be to update our statement of works so that we get exactly what we want from industry with regards to them leveraging this data standard? Or can I reference to documents that already exist and would be quite prescriptive on them? I hope I'm making sense.
Yeah, no, that makes perfect sense. And that's something that report, it does start to hint at. We're trying to update it more, but it's basically a two-person effort. But what we're trying to do with that is attract contractual language that has worked or not worked in the past and try to provide sample language that help you get at what the standards are. I mean, one thing we try to do is we try to make all these standards self-contained where you should be able to say, I want learning metadata. I want all the content objects at, say, the lesson level or higher to have every property from the learning metadata term standard populated and the course profile as documented here. So we're trying to make it so that the technical components of this end up being something they can reference and then pull the requirements out of there. But sometimes it does help to not just give them one line, but multiple lines to let them know how they're going to be assessed. And then I'd say it's find vendors that are reputable and know what they're talking about. They should be able to provide an example. Like, hey, give me an example of a course that's tagged that you have for CMI 5, even if it's a dummy course. Give me a course or give me a record. I'll call it a record. Metadata records are kind of going away with graph technology, but give me a screenshot or a snapshot of what metadata looks like for one of your courses if the LMT standards applied. So I'd say a lot of it is in the acquisition language is important, but also in how you vet the people who are applying for those contracts.
Yeah, I think we already have the vendors we're going to be working with. So, but for future projects, note taken. Thank you.
Yeah, just make sure try to hold them accountable.
Yeah. So on behalf of the Navy TDOs, thank you very much for taking the time and doing this presentation.
You bet. Anytime.
Andy, great presentation as usual. Max, just so you're tracking, I've tasked Matt to come up with a document that can be shared with vendors that will support the TLA standard and everything going forward. So He's just started work on that, and we'll work with C-ADL and a bunch of our other partners to pull something together. Okay.
Thank you.
Sounds great.
Andy, we did have a comment in the chat saying, thank you for the presentation. For someone looking to become more educated in this space, what technical training or resources can you recommend? There was some recommendation further down on basic intro at Jeff Batt's site, and it was listed in the chat. But do you have any other suggestions?
Yeah, it's our site, adlnet.gov. That's a good site. We have a lot of our past information there. I'd also say in the DoD policy there. So I'll put this is on adlnet.gov. And what I can do too is I can work through Stephen, and I do have a series of I do a lot of links in presentations I've given, so I can refer back to those and link. A lot of it's technical, but it should be useful. The other thing we're really trying to do with IEEE standards is get them all out there so that they're open source. So let's see. Let me just do a quick search. So I can link our repository here. So these aren't the specific standards, but one thing in the standards development process, what we're trying to do now is create these artifacts that essentially have the subject matter of the standard. It doesn't have the teeth. So when I say that, it's not the published standard. So I would say if you are working with people, that somebody should have a copy of the standard. But if you're trying to understand what's going on in the standards, the access to the information is now much more available. So I've linked, this is the learning metadata term standard I referred to. So you can read all that, it's all free. The technical standard, again, the subject matter isn't really different from that. But but if you want to get the background of what what you're going to be buying, what types of requirements, that's really good. I'll link the since I'm not sharing anymore, I can pull the link off this and link that acquisitions report as well. I would start with both of those. There's links in the acquisition report as well, so it is kind of going to be a spider document. So if you start there, you can grab the links from there. Sorry that the text is so large there, but that's where I would start. I'm always available too, so if you want to reach out and ask questions, or hey, I'm looking for a resource that teaches me this, I can probably link you to either the resource or to somebody else. I do. It's not very well managed. Let me pull it up. Because I haven't changed jobs in so long, I kind of look at LinkedIn as a.
We do have another question from the group.
Oh, go ahead. Yeah, fire away. I'll pull up my LinkedIn profile while you're going. I used to know, if you look at Andy Johnson ADL LinkedIn, I actually may even find it myself. I'm never on there because I connect to people through a lot of different circles of activity, but I'm not actively looking for a new job and haven't for a long time. So my LinkedIn is not very well updated. Here I am.
Ruben Ellett, you had your hand up.
I did. Good morning. Just had a question around defining and shaping this. So for us at the moment, we're currently scoping, working with vendors to, I suppose, build a system which is capable of ingesting XAPI instrumentation for the New Zealand Defence Force. The point that I'm at is there's a lot of unknown here. Even within the market within New Zealand, people don't really understand it that well, which is why I'm having to link them up with providers who have worked with C-ADL in the past for them to understand what these standards are and how to implement them, that sort of thing. Should all this be considered up front as part of a system design? Like you really need to map the stuff out and understand what questions you need to ask from your learning metadata and everything else? Or based on the maturity model, can you just take that initial first step and just effectively treat the XAPI instrumentation as a replacement for recording course completions, like at its lowest kind of granular level?
Yeah, you can certainly start there and expand. I mean, XAPI is a little bit different in that way from learning metadata. Learning metadata definitely recommend starting to tag things up front and know what you have. But obviously, you're going to have some technical debt that if you want to go back and apply standards to learning metadata terms, you can still do that. But for XAPI, I would always say jump right in, do the basics first, and using something like CMI5, even if you just do the statement types that CMI5 does. CMI5 at its core is 9 defined XAPI statements. And if you can contextualize the rest of your statements around those, now you will know that, all right, the learner was involved in a session that was initialized. And then within that session, they watched a video, they took part in a simulation. And in that simulation, they moved these objects, they did this thing correctly. You have all that now contextualized. So you can keep iteratively adding different things that you want to track within your content. Video is probably the easiest example because there is a video profile that has about 10 different XAPI statements that have to do with the controls you're interfacing with while watching a video. You can easily just bolt that on to CMI5. content, add that later. If it's, let's say later you want to then interact with, let's say they're in an LMS, you can bolt it into the LMS. So we use Moodle, for example. There's Moodle log store events that you can just tie in XAPI statements to. So when we talk about webhooks, as long as there's something that's an event that calls like say a programming method. So if I'm going to do a forum post and I hit submit, there's a submit button. That means I have a web event associated with saying somebody actually made a forum post. I can now grab that same data and make an XAPI statement about it. So I can track learners both inside the learning management system and inside content itself. And those can be a real benefit to each other, especially if you connect that to learner success. Hope that made sense.
It did. Thank you.
I can keep taking questions too. I don't have a hard stop. So
thanks, Eddie. I was just going to ask that.
Yeah, go ahead.
So for those who do have to get going, I am cognizant of the time. I just want to let everyone know that the next speaker series is going to be on the 20th of November. I do invite anyone who is able to stay behind. We will keep on taking questions and carry it on from there.
And if you do have to run, there will be a recording of this available by early next week. And I will kindly ask Andy if you could share his PowerPoint with us.
Oh, yeah, sure.
I'll publish that alongside it so that people can go through. Thank you so much, sir.
Yeah, you bet.
And I'll defer to Mr. McCann with his question.
Thanks a lot. Hi, Andy. Thanks for this presentation. It's been very informative.
Yeah, you bet.
Could you provide maybe some guidance on where to include additional metadata in XAPI statements? So things like UUIDs, references to documents, objects within other systems in our total learning architecture. We've considered options like using the extensions field. But since XAPI doesn't strictly define where the status should be, recommendations would help because we had a lot of back and forth about.
Right. So I would use object. So object extensions is where you're going to want to start. So there is metadata defined in the object, and I think it's just name and description. But all that you can keep extending that. So it's more important. So what I would say is, that only has a limited amount of value added. So what I have seen is implementations where people decide to rely on so I'm trying to debate how technical to get. So XAPI has a learning record store, and learning record store, a lot of people are familiar with as sending and retrieving statements, but it also registers every activity within it, within an activity profile. So every time you have an XAPI statement that has an object, that object, it has an identifier to it. Every unique object identified there, which is what I would say is the most important thing, is catalog and keep track of the unique object IDs you're using in XAPI statement, and do that in a way that is consistent and documented. What you want to, and if you can have those identifiers also resolve to a place that returns the metadata. So at each of those IRIs resolution points, you just have a JSON document that is the metadata. That's probably ideal. But in the absence of that, if you just wanted to get some basics, and you don't, and that identifier is not going to resolve, the LRS should and is required to track all of the data and tag it as such by that unique ID that you put in that object property in XAPI and any extension under it. So you could then, if you wanted to, introduce a full metadata record of all of the different terms that you learning metadata terms and properties you want to use. And I would test that out and see how your LRS responds to that. I know some of them actually are tracking this learning metadata term standard, and we'll have actual they're actually anticipating those properties. So then if you're running analytics and things like that, or running searches, it can help you out. Ultimately, though, what you want is some sort of end user support for the metadata properties. So I wouldn't get too crazy in connecting all the properties within the statements themselves or the resolution points. I would just make sure that those activity objects are known, are registered, and you do have a metadata record associated with them, so that when it does come time to letting those records get ingested by some sort of global system, that you're already ready. And if you do have that local capability to search it with your LRS, LRS might be a really good tool for that. Otherwise you might have to rely on other tools. I hope that answered your question, sir.
Okay, thanks. I'll have to chew on that.
Okay. Yeah, and if you want to connect further, I put my email in the chat. So if you want to think on that, and then we can get even more technical if you want. And I can work better sending you specific code examples and stuff like that.
Thank you very much.
Mm-hmm.
And on that note, I think we should probably wrap up and not take any more of your time, Andy, right now, especially if you're volunteering to answer further questions from us by email. So thank you so much. It's an amazing presentation. It's going to echo everyone else who's spoken today and say thank you so much for that. It's going to really help us on our way to implementing learning engineering standards within our organization, within our training. And I want to say thank you to Major Stevens. Thank you for everybody for sticking with us and coming out today. And please join us again November 20th. That's a Thursday for Dr. Summer Rubensky, and her presentation is on how modern technologies fit into the training ecosystem. So thank you very much, and we'll send out links to that coming up soon. Thank you, everybody, and everybody have a great lunch and a great day. Thank you very much.
Thank you all. See you later.